Okay, so we have a question about double angles. So the question is, find the values of sine 2 theta, cosine 2 theta, and tangent 2 theta for the given value and interval. So the first one just gives you cosine theta equals 3/5, and then they give you the interval. So this interval right here is going to be the fourth quadrant. So I drew up my Cartesian plane and I made these quadrants 1 through 3 smaller. And then this is the fourth quadrant. That's way bigger. So I'm going to use that for my reference triangle, which we'll talk about in a second. Let's jump over here. Sine, cosine, and tangent. Oh heck, another hour of algebra. We're dealing with cosine right now. So adjacent over hypotenuse. So we know the adjacent is 3 and the hypotenuse is 5. So a way that we're going to double check now is we're going to think, what are values that are positive in the fourth quadrant? Is cosine positive in the fourth quadrant? Yes, it is. So that's good. We know that we're on the right track because we had a positive value for cosine here. All right. The other thing that we're going to think is when we look at this, which one is like intuitively going to be positive? This one. This line is positive. This line on the y-axis is negative. So whatever our answer is for, see if we can just erase that, for this line, for this opposite line, the line opposite the angle, it's going to be negative. So we'll go ahead and write a negative here. And then you probably know that this is a certain kind of triangle, a 3, 4, 5. So this side is -4. So I'm just going to erase this question mark here. And we've got a -4 for our opposite side. All right, so now that we've got our sides in our reference triangle, we're going to find sine 2 theta, cosine 2 theta, and tangent theta. So sine, whoops. All right, sine of 2 theta, I'm going to just zoom back out for a sec. Okay, so sine of 2 theta equals 2 sine theta cosine theta. Oops. 2 sine theta cosine theta. So it equals 2. Now the sine theta is opposite over hypotenuse. So 2 times opposite over hypotenuse is -4 over 5. Cosine theta is adjacent over hypotenuse, so that's 3 over 5. So it equals 2 times -4 times 3. So we're going to multiply all 3 of these together. We're going to get -24, and 5 times 5 is 25. So that is the answer. Okay, we just have 2 left. Cosine 2 theta. So up here, we've got this. There are 3 identities that you can use, but I like this one. So it's cosine squared theta minus sine squared theta. So the cosine squared is 3/5 squared. So we just found that up there, or it's adjacent over hypotenuse. And then sine squared is opposite over hypotenuse, so that's -4 over 5. So you'll notice that no matter what your cosine term is, no matter what your sine term is, they're all positive. So what matters is when you square it, which one is bigger, and that's going to give you the positive or negative answer. If cosine is bigger, then your cosine 2 theta is positive. If sine is bigger, then your sine 2 theta is positive, and it doesn't matter what the signs are. Forgot to put a little exponent. Okay, so we have 9 over 25 minus 16 over 25. So that equals negative 7 over 25. Easy peasy, as my child would say, easy peasy, lemon squeezy. All right, so I'm gonna just scroll up a little bit. Okay, so now we want to find the tangent of 2 theta. So this one is kind of a nastier equation, but it's really still not too bad. So tangent of 2 theta equals 2 times the tangent of theta is going to be, oh heck, another hour of algebra. That's going to be opposite over adjacent. So negative 4 over 3. And then it's all over 1 minus, again, tangent theta, negative 4 over 3 squared. So that equals, multiply this, negative 8 over 3 over 1 minus 16 over 9. Okay. So now on the bottom, we want to get a common denominator, so we just have a normal messy fraction. So negative 8 over 3 divided by 9 over 9 minus 16 over 9. So that equals negative 8 over 3 divided by negative 7 over 9. Now let's multiply both sides. 9 over 7. And we're going to make them all negative. All right, so this totally cancels out. And now we're left with positive 72 over 21. But, you know, we could have canceled things out here, but we know that we can divide both sides by 3. So that's going to be, let's see, 21 divided by 3 is 7. That's easy. This is 24. And 7 and 24 do not have anything that you can take out of them. So the tangent of 2 theta is 24 divided by 7. 24 over 7. Or 24 sevenths. However you want to say it, these are the 3 answers. So let's review the steps. Number 1, as soon as you get your test, you're going to write up in the corner all of your identities, not just these, also your sine squared plus cosine squared equals 1. You're just going to write everything. This will kind of help you feel grounded. Then go ahead and draw out, look at your interval and draw it out. And FYI, if you're not sure where the reference angle goes, think of it like a bow tie. So you've got, depending on which quadrant it's going to be in, draw your bow tie, and your reference angles are these little pieces right here in the bow tie. So you're going to draw your reference triangle. You're going to label what you know, given your statement, whether it's sine, cosine, or tangent. You're always going to have two sides to label. You stop and then you double check your positive and negative signs. Make sure it makes sense with your drawing and what you know. And then you can go ahead and label your opposite, adjacent, and hypotenuse. And you find your other side. Might be a special triangle. It might be something that you have to do the Pythagorean theorem for. Then just plug and chug into your formulas and you're good. I recommend using this tangent 2 theta formula instead of the sine over cosine formula. But you'll notice you could have done that and it would have been the same answer. So, awesome. Okay, yay. Whoa. Huh. Okay, there we go.